Welcome to Cpp.chat, a memory-safe look at what's going on in the world of C++ and beyond, chatting with guests from the communities. But before we get too rusty, John has something he needs to say.
Thank you, Phil. Cpp.chat uses premium paint on all exposed steel on your trailer, including the undercarriage. However, no paint will last forever, and when the paint is diminished or gone, rust and corrosion of the steel is inevitable. If you wish to keep your trailer rust-free, we recommend that as part of your routine maintenance, you examine your trailer and apply black Rust-Oleum or a similar product to any place that has begun to rust.
I'm not sure your disclaimer has been taken seriously.
Well, it's because I didn't deliver it well, because I'm a little bit rusty on that.
Yes.
People who are particularly attuned to listening to subtle details may have figured out the topic for our talk today. We have, I can't even count them all. We have 5 guests, right? So did I get that right? Okay. So should we go around and introduce ourselves to start with? I'm going to, I should do it alphabetically, but I'm not going to because I will get confused. And so I'm just going to do it in the order they appear on my screen. And so I'm going to start with James and ask you to introduce yourself and tell us a little bit about how and why you use Rust.
Sure. So I'm James Munns. I'm a managing director and embedded systems engineer at Ferris Systems. My background is in primarily embedded systems in the safety critical and connected devices areas. So things like avionics, robotics, IoT, all that fun wide range of embedded things. I started picking up Rust 5 or 6 years ago. I was working at a safety critical company at the time, and I read some of the promises on the pre 1.0 blog post, and I went, yeah, if it does all of that, that's pretty much going to be the next thing in safety critical development. So I started picking it up and now slowly trying to work it into safety critical development.
Okay. Most of our audience, I think, should know who Jason Turner is, but Jason, just say a little bit about yourself and what your interest is in Rust.
I feel like I have no idea how to introduce myself anymore. I do YouTube podcasting, training, speaking during a normal year, and contracting for C++. Host of a YouTube channel and podcast. My interest in Rust is, mostly because my cousin, who used to be on the Rust team at Mozilla, said, hey, you need to be trying Rust for several years before I went ahead and said, okay, let's give it a go. So we did a couple of multi-hour live streams where he taught me some of the basics of Rust, and we went over some simple projects and stuff.
Okay. Alina, tell us a little bit about you and your interest in Rust.
Hi, I'm Elena, and I work in a plant growing game with an engine written in Rust as well. So I developed the engine and the game. And I used to work with C++ in embedded systems as well.
Okay, thank you. And Nicole.
Hi, so I am a software engineer at Microsoft. I work on the Visual C++ team on the VC package manager. So we hope that it will look something like Cargo for C++. My interest in Rust is I've always been a language nerd, and I kind of grew up, did most, high school and a little bit of college. I was in the Rust community. I worked on the formatting guidelines. I worked on the unsafe code guidelines team. And I've mostly switched to C++ nowadays because I wanted to work at Microsoft, and they don't really do a lot of Rust at Microsoft, at least on the compiler teams. But yeah, I think that's it.
Okay. All right. And Jan?
Oh, did John freeze?
It's in Rust.
Yep, he's back.
Hey, okay, great. I could hear half my name there, but yeah, hi, I'm Yash. I used to do a lot of JavaScript. I currently work as a software engineer at Prisma. We build database drivers, so I get to work on that for most of my workday. But I also am deeply invested. I do a lot of async Rust, HTTP framework, protocol kind of things. It's mainly what I do, and most recently also like front-end WASM kind of things. But yeah.
All right. So my first question is to Phil. Why are we talking about Rust on a C++ podcast? You did some events, or at least one event in London with the Rust group there, and I think you've been told to give a shout out to the local Rust group in London. Is that correct?
That's right. So I've actually been going to, obviously I run C++ London. I've done for 4 years now. For the last year or so, I've also been going to the Rust London Meetup, where I've been talking with the organizer there, Ernest. And we've had this plan for a while to actually create a new sort of crossover community of people that are interested in actually potentially any native language. I think we've got a lot of commonality that we're not really tapping into because we tend to silo a bit too much. As you've seen from our introductions, everyone here has a bit of a foot in both camps to one degree or another. And certainly the people in the upper echelons of the community tend to be like that. But for a lot of people, we do tend to fall into these silos. So I wanted to start working on creating a new community for that. So just to test the waters, we've got our two communities together, and C++ London and Rust London met up together last month for did some talks introducing Rust to C++ developers, and then what you can actually do with it. And we're going to follow up next week actually with another joint event where we're going to have some more Rust talks. But then we're going to go back to our sort of normal C++ and Rust silos. But hopefully that's going to get us thinking about how we can actually learn from each other's communities rather than treating them as sort of us and them, which sometimes can happen. We don't really want to go down that route. So but while people are interested in this, because we've got a lot of positive reaction to our joint meetup, thought we should re-engage our podcast, which has been a bit quiet for a while, with also another crossover event. So get some people from both sides talking and see what we can learn from each other.
All right. So who wants to give us a quick history of Rust for people in the C++ world who've probably heard of it but don't really know much about what's going on there? You're smiling, James. Does that mean you...
I've given, so I do a lot of Rust consulting, so I've given this kind of talk a bunch of times. So I'm happy to take the lead on this one. So Rust is a programming language that came out of Mozilla in the pre-C++ 11 times. They were having kind of recurring year-over-year problems of writing safe C++ in a way that didn't crash the browser or didn't cause problems or performance issues. And they looked at a couple different languages, and one of the engineers there kind of went, hey, well, I have this side project that I think could be a thing. And brought it up to Mozilla, and it got worked on at Mozilla for a while. Then kind of leading up to 2015, it went from being a private Mozilla project to a public Mozilla project, and eventually kind of emerged as the Rust 1.0 that most people are familiar with today. There's a lot of history I'm skipping in there, but since then, Rust has been kind of an interesting case study in both community management and kind of another systems programming language that's aiming to fill some of these areas, whether it's back-end development like Yash is working in, or embedded development like I'm working in, or game development like Alina's working in. It's been a language that people seem to have a lot of fun using and make some pretty strong safety guarantees around how it's designed, and has generally become a language that a lot of developers have found themselves really enjoying using these days.
Okay. So, Alina, I haven't heard about people using it for game development. I have heard about people trying to do, obviously, a browser with it and low-level system software, but I haven't heard about people doing game development. What is it attracts you to Rust for game development?
So this is a good question, because normally if people would ask, what engine would you use for game development, or how would you start with game development, I would say that you definitely should use an existing game engine like Unity or Unreal if you want to ship a game in a realistic time frame. And if you don't have any specific requirements that really need a custom engine. But what we're working on actually benefits from a custom engine because it's a unique plant growing game where if current literature kind of talks about semi-realistic plans that are very computationally extensive, then we have our own algorithms and systems that make it feasible to create pretty much realistic trees on a large scale on non-kind of gamer or non-expensive GPUs. So for all of this and the game world as well, we had to work on a custom engine, and this is my primary role right now, to work on the engine in Rust. And in such projects, it's usually like the game code and the engine code is really intertwined. You cannot really say, oh, this is the engine and this is the game, because it's not an engine like Unity where you have like a graphical user interface and so on. But either way, I mostly work on the engine side. And what attracted me to Rust personally is that when I worked in embedded, I think it's a philosophical kind of divide actually between the Rust and the C++ communities, in a sense, when we are talking about like good code or bad code, as we were talking about a little bit before, is that, in my opinion, for example, things like lifetime issues or kind of tracking a lifetime issue in a code base, stuff like this could be actually offloaded to the compiler and not the engineer. So I was exploring alternatives, and I really enjoyed my first experience with Rust, and I started kind of experimenting with graphic software because it combined the embedded kind of low-level side of things with pretty pictures, and that's how I also started working on the game that my core creator started on before.
Okay, so are you thinking that if someone was going to do a game engine from the beginning, from scratch now, that Rust would be as good or better than C++?
So this is hard to say, because essentially there's a lot more material on game engine architecture, or just game engine code floating around the internet for C++. So if you're starting off writing a game engine for the first time in your life, then it's much easier to start off with C++, because there's just so much material. You can ask people and so on. But in Rust, there's really, if you need to rely on tutorials or something like that for game engine development, then if you have no experience with a language like C++, for example, and you're reading old books on game engine architecture or just game engines in general, and you are not able to kind of relate that C++ information with Rust code and how to do it in Rust, then you will probably have a harder time.
Right. So this is
yeah.
I was just going to say, this is the classic trade-off with any established language, right? The established languages always carry a lot of baggage, including lots of mistakes that people made in libraries and decisions along the way. But they also have the momentum of, as you said, lots of books or other information out there on how to do things, because that language has been around a long time. So this is the obvious and continual trade-off between established languages and languages where the entire language is greenfield, right?
Yeah, but I think if with game engines and games, mostly people who are interested in making their own games and game engines start off really young. That wasn't the case for me, but if you're an experienced developer who's experienced with other languages and kind of architectural issues, then you can pretty much write a game engine in any language, basically. Mm-hmm. That's not a problem. But if you're a young person starting off, there's more resources and materials to do how to make an engine in Rust, for example, than there was a year ago. So this is changing very quickly. And I'm planning on writing a couple of tutorials myself, but that's going to be a lot of work down the road. But But if you're young, then it's probably easier to kind of look towards C++ and seek help there than it is in Rust. But I think it will be different in even a year from now.
Okay. All right. Yash,
I think that
can you
really.
tell us- Oh, sorry.
sorry, go ahead.
James. No, go ahead, James.
I was going to say that really matches my experience in embedded. So when I started looking at Rust, there were like 5 people who had made Rust work on embedded. This is like really close to the 1.0 time. But there was definitely a couple people who were really excited about it, and that's kind of where I got looped in. But for that first year or two, it was just kind of a small crew of us that were, you had to know the ins and outs of the compiler, the like how embedded hardware works, how C worked, and how Rust worked to really get something going. But that's one of those things that I've seen Rust communities be really good at that matches Alina's experience about kind of realizing that's a thing. A couple people kind of go in and build the bridges and start writing documentation and things like that. And I think it took us maybe like 18 months or so before we had embedded system support stable in the compiler from then. And then since then, we've been writing books and things like that. And as you mentioned, I totally agree with you, John. There's if you look at embedded, there's way more C and C++ examples than there are out there in Rust. But definitely, like Alina said, we're closing that gap fairly quickly, which is making it hopefully a lot easier for folks to get into that. But it's interesting to hear that from the game engine kind of perspective, because it really, really matches the experience that I've had with embedded as well.
And Yash, what has your experience been?
Oh yeah. So I was really interested in like doing any kind of networking in Rust, and I ended up having to write several asynchronous runtimes in order to get pretty much anything done. So I can relate to what's being said right now. Where it's like, yeah, a couple of years ago, things weren't as good as they are now, and you can really see things progress really fast, which is great. But also, every now and then, something doesn't exist, and you really, like, people are like, why doesn't it exist? And the answer is like, well, you know, nobody did it, and then you need to write it, and that becomes a thing. Yeah.
So do you feel like some of what you're doing is just creating something that other people are going to use, really fundamentally foundational kind of stuff, because you're so early?
Yeah, we've had to do that like several times over. For example, when in 2018, async await didn't exist. Like nothing around async await properly existing in the ecosystem. We weren't sure how it would like pan out. So part of it was building libraries, but part of it was also evaluating the design of a language feature. A lot of these things have like been evolved in lockstep, and currently we're like expanding on async await still. And very foundational things just need to keep being written. And yeah. It feels definitely early days for Rust for some fields, but some other things just, the pace at which they're being developed is really encouraging, I think.
It's one of those things that I've seen kind of over and over in the Rust community is there's a lot of people who are willing to jump in and design from the field from scratch, but as Rust has been kind of a language that's been online from kind of day one, where a lot of these decision making processes have happened out in the open and in public and things like that, that people are really happy to design things, iterate on them, and then document them and then share the code so that the ecosystem does kind of make a step whenever someone makes that step of design challenge. And sometimes we've gotten the design wrong on the first time, and sometimes it's iterated a couple times, but it's been really interesting to see the community move step by step together rather than kind of these siloed, oh, there's this group over here at this company that are doing things versus this group over here that are doing other things.
Yeah, on like kind of along those lines, one of the things that's really nice about Rust is if someone writes a library, anyone can use it. There's no like, so this is coming from my experience as a package manager writer. In C++, unless you're using something like VC Package or Conan, which are very new projects and are not established in the community, if someone has like a library somewhere, it is a pain in the butt to like figure out how to get that library, download it, build it. If you're uploading your project to GitHub, you have to like tell your users how to get that library. Whereas in Rust, if someone does something, you have access to it through crates.io. Whereas in C++, even though the library might exist, you know, it might be a giant pain in the butt to get it working. Like Eigen, for example, is a great example of like a great library that is incredibly difficult to actually get working because it's so old and legacy, and like it takes a huge build system and, you know, all that kind of stuff.
What does Eigen do, out of curiosity?
It's a linear algebra library, basically. Cool. Does all that kind of fun stuff.
Thanks.
Yeah.
I should throw this in every once in a while. That was Nicole sharing. For people who are on audio only, and we have 5 guests, so it's going to be a little bit hard to keep track of people. So every once in a while, I'll point out who said something. So Jason, what is you said that you got interested in this because your cousin was interested in it kind of in a very low level, or I should say low level, early stage, and so you've been following it, and but you've also very, very aware of what's going on in the C++ world. What's the difference between the two worlds?
I don't think if you mean like from a social aspect, I guess.
Yeah,
of the
what
world.
are the communities? That's what I mean.
I don't spend any time in the Rust community, so I don't think I can say anything about that. I only know basically my cousin and Nicole from early on. I knew that you were involved in both the Rust and C++ communities several years ago. But other than that, yeah, I can't really say a whole lot about the communities. I don't think that would be fair for me to.
Okay, a little unfair. Maybe I should ask Nicole that same question then, because you have been involved. But now you were involved with Rust early enough on that it wasn't yet 1.0, right? So before it got to that point, the assumption was that they could break anything at any time if they thought it was a step forward, right?
I got involved at 0.12. So the way that Rust development worked was there was a whole bunch of changes from 0.1 to 0.11. And then in 0.12, they started stabilizing for 1.0. So I actually got involved right at like the beginning of the stabilization process. So I didn't experience a lot of that initial like breaking changes every day or whatever.
Was that part of your experience, James? Were you in early enough that you saw that?
I was mostly a passive observer until right around 1.0. So I kept an eye on the project, and sort of like my attempts to learn C++, I took a couple stabs at it and didn't really land on the first couple tries. But it was actually sitting down with some folks at the first Rust Fest where I sat down with some folks from the Rust world, and Simon Sapon from the Rust project, he just sat down with me and was like, oh, no, it's like this and this and this, and it clicked. But so I definitely haven't been involved from the early days, but definitely have been involved since the 1.0 kind of actively, and then being part of the embedded working group for the last couple years or so.
So you mentioned the working group. Is this is there a structure that's comparable to what we have in the C++ world with our ISO standards committee? Is this, it's not ISO, is it? Rust is not an ISO standard at this point yet, right?
No.
But
so
there is a working group?
Yeah, sure. So the way the Rust project works, and I'm not familiar with the C++ organization, is that we generally have a couple of teams. So there's the core team who's mostly looking at the language and where the language is going. And then we have a couple main project teams like T-compiler and T-lang, which are generally focused on the language itself, the compiler itself, libraries, things like that. And then typically working groups will pop up to address specific concerns. So there were things like the async working group. There were a number of compiler performance working groups, where these tend to be more short-lived projects that have now typically a singular focus. That process has also been refined over the last 5 years or so, so it's definitely changed over time. The embedded working group is kind of the one weird example there that we've kind of stuck around. The original plan was to get embedded stable in the compiler, and then we just kind of kept sticking around and doing things. So the embedded working group's kind of the one weird one out, but usually we have project teams like core or lang or compiler. Working groups pop up to tackle specific problems every now and then. And yeah, generally it works sort of hierarchically like that, but it's a pretty relaxed kind of group of people. And there's no ISO standard. It's really just self-organized through the open source project itself.
Right. Right.
I would compare the working groups to C++'s study groups.
Yeah. Okay. All right. So is there, I noticed from your shirt that there's a Rust Conf. Is this an annual meeting where, what do you call yourselves? Rust heads? I don't know. Where Rusties get together and
Rustations, yeah.
Rustations. Yeah. Okay. All right.
Yeah.
I like that.
So there's a lot of conferences. So RustConf is in the US in Portland. Rust Fest is the main one in Europe, which kind of moves around a bit around Europe. Ferris runs a conference called Oxidize, which is embedded systems focused. But there's conferences all around. So there's Rust Japan, Rust Tokyo, Gold Rush Rust. There's been a couple across Europe. So there's RustConf is yearly, and it's probably the biggest one. Rust Fest is twice a year, and it's probably the biggest one in Europe. And then there's a lot of smaller or more specifically focused conferences as well. There's a lot of people who come from like the Ruby and JavaScript conference organizer scene that have moved over to the Rust world. And I feel like they've taken a lot of the traditions from the Ruby and the JavaScript world in terms of having conferences and meeting regularly and locally.
I see. And is there much overlap between the conferences and defining the language, or are the conferences mostly for users?
I'd say it's mostly for users. You happen to usually get a lot of the core team together at these meetings, particularly RustConf in Portland, because a lot of people are in the US or Europe. So usually at Rust Fest or RustConf, you usually get a fairly large delegation of folks from the compiler teams on either the European or the US side. But they're not really set out like an organization of a meeting of the elders. It's much more just focused on the conference and the event and things like that. And if you happen to have everyone in the same city at the same time, you might meet up and have some chats about things, but it's not generally scheduled like that.
Usually conferences have like one or two impul days after a conference where people just go into a room and like work on projects. People who haven't like contributed to the compiler before. Someone like helps them land their first patch, tackle their first feature. But also people like who are on the same team, for example, get a chance to in person talk about particular language features.
So that was Yosh. And so did you work on the team for async? I mean, were you part of a formal?
Yeah. Originally, it was the networking working group, and then we split it up into two different teams. One for the language aspect of async and one for the ecosystem part of async. I was more on the ecosystem side. But I'm now involved with the language side again, so kind of bouncing around.
I see. Okay. So one of the things I'm curious about is the equivalent to what C++ has in the standard library. I mean, how much library is there that is just assumed to be there, and how much of it comes from cargo? I'm trying to figure out. Is there a blessed, this is the official library, or is that just, no, we just have an ecosystem and there's a bunch of libraries and you take the ones you want? I mean, is there a sense of that?
So the Rust standard library is very similar to the C++ standard library, I would say. They have most of the same things. I think there's like minor differences. I think like the Rust standard library has like IP addresses and things like that. Not any actual networking as far as I know, but just like the basic types for that. Do you know?
Yeah. We have TCP, UDP.
Oh,
I know.
Did that happen recently? I don't remember that being in the library.
Ever since, at least for 3 years, pretty sure.
Really? Okay. Well, clearly
we'll get it soon.
Knowledge is a little bit outdated. But yeah, they're very comparable. Like, I can't think of anything in the C++ standard library that the Rust standard library doesn't have. And I can't think of anything in the Rust standard library that the C++ standard library doesn't either have or want to have very soon.
Does the C++ standard library have random numbers?
Yeah.
Random number generators?
Oh, we've got all sorts
then that's
of
probably the
random
one.
generators.
Oh yeah. Rust doesn't have random numbers, does it?
Yeah, so rand is one of those libraries that's been there for forever, but it's not part of the standard library. So there's a couple things in Rust that are not there. But I'd say probably in terms of size and scope, they're pretty comparable. There might be a couple mismatches. The other thing is that Rust has generally split up the standard library into core and standard. There's a little bit more detail there, but core is the stuff that doesn't make any assumption about what your environment is, like you're not running on an operating system. So for embedded systems, we use the core part of the library. And then there's the standard library, which does have things like networking and sockets and files and things like that. And it's pretty much a strict superset of the core library. But they have at least done a good job of splitting those up. So if you don't have an allocator, you don't have an operating system, you still get most of the Rust standard library, but not the parts that have to do with heap allocation, collections, file system interactions, network socket interactions, those kind of things.
Can you do custom allocate?
Oh, and it's important to understand that you can actually add in parts from the standard library that isn't the full standard library. So it's not like C++ where you have freestanding and not freestanding. Although I will say something about freestanding is really not great and not well done in C++, and we need more work on it.
But you could pick and choose, so you could take like the networking stuff without the file system stuff or something like that. Is what you're trying to say.
Like collections are a big one that people take without the rest of the, like IO, for example.
And collections are containers?
Yeah.
Okay. All right. Well, what I was gonna say is, if you're interested in random, the C++ world has figured out a lot of things not to do and managed to get them into the standard. There was a podcast earlier this summer that you did, Jason. Who was the guest on that was talking about random and?
Is that Corrington? No.
Yeah.
Is it?
No, it wasn't. It was. No, I don't remember who it was, but he was talking about how, we initially had rand, which from C, which had some issues. And so we fixed all those with C++ 11, and we introduced this great random system which handled different kinds of distributions and different kinds of generator engines, only to realize that, well, one of the things that people wanted out of a random number is for it to be to deterministically generate a series of random numbers, and it wasn't set up to be able to seed and guarantee the exact results repeatedly on different platforms and things like that, which is one of the things that was, for some use cases, that's really important. Other use cases wouldn't want that at all. They want them to be as non-deterministic as possible, actually want them to be random. And so you have these different use cases, and you design with one in mind, and you shoot yourself in the foot. What were you going to say?
Martin.
It was Martin. Yeah.
Yep. Martin Aronofsky.
Yeah.
Right. Oh, but what I wanted to say about that was, the thing that C++ did was we didn't even do it well. Like, there are random number generators that are totally fine, and we standardize the pseudo-random number generators, but we don't standardize how you get from the bits to the range. So we have a thing that takes random bits and outputs an integer between 0 and 100 or whatever. And we didn't standardize the algorithm to go from the random bits to the range. Yeah. And so the different implementations do it differently.
Right.
And I don't know why we did that, but it's really not good for cross-platform at all. And there was no reason for it.
Well, I mean, no. If you don't specify it, then you can optimize it in different ways. But the question is that a requirement? And for some situations it's not. For some situations it is. And that's what we overlooked, was we didn't have the requirements quite right. We left out some really important use cases, I think, is the problem, right? There were just some use cases where, no, that's what we want. We want to be able to say, I don't care what platform I'm on, given this seed, I should always get a predictable set of numbers. And that wasn't considered a use case.
Yeah, I think this is part of the reason why Rust never standardized the RAND library, because I think they realized this one was a hot topic, and they learned from people in the past, and they went, let's keep that in a non-blessed external package, so at least at some point we can deprecate it and switch to something else. But the Rust standard library has been pretty good about keeping contentious items where it's not the design space isn't 100% known, and there's been a lot of different languages that have gotten different things wrong over time, where they go, that goes in a crate, and it's easy because everyone can just depend on the Rand crate, and if 6 months from now we realize a way better, more flexible way of doing that, then we'll just have the ecosystem switch over to another package, because it's as easy as changing the dependencies.
So I'm curious if the Rand crate in Rust has reached this, or Rand, I'm using Rand as an example, but the common crates have reached the kind of node situation where you request one crate and you have to install 10,000 tiny dependencies to go with it, or not?
It probably depends on the domain you're in.
Okay.
For like web programming, very much so. Like you pull in like a slew of things because, for example, you might want cookies, which pulls in like some sort of cryptographic thing for signed cookies, which has base 64 somewhere, which like pulls in another thing. But a nice effort that's been going on for quite a while now is to move small packages, small crates that exist in the ecosystem that see very wide adoption back into the standard library, which sort of presses the number down again.
See, I think
sense.
I think if you have a better package manager, which clearly Rust does, that takes some of the pressure off of putting things into the standard prematurely. I think this is one of the problems that we have in the standard library in C++ is that people say, well, we can't rely on people, some people can't use Boost, so we have to put this in the standard or they don't have it. It's like, I think that's very bad thinking. But you have that pressure that says, well, there's some people whose companies only allow them to use the standard library, which is like, well, fix the company, don't destroy the standard for that reason. But if well, here's the alternative. The alternative is this is a package that's just out there and you have a good package manager and you can pull it down and we could fix it later because we haven't blessed it yet. That takes a lot of pressure off you, I think, and is going to mean you'll make fewer mistakes and can recover from them more gracefully when you do.
A very good example of where this went really wrong is with std regex, where we expected standard library implementers who have no experience with regexes to implement a regex engine that has like 5 different ways of matching regexes.
I think it's only 4.
It's only 4? Okay. But like they have like the ECMAScript way, the Perl way, I don't know the other ones. But like, and we just expect standard library implementers to be able to do these kind of things. And they are not regex experts. Whereas if we had Cargo, someone who is actually good at writing regexes, who doesn't have to deal with ABI compatibility, which is another huge thing in the C++ standard library, we would just be able to have like one cross-platform regex library that does everything that you care about and is actually fast. But we don't have that.
We're lucky Rust has Burnt Sushi.
Yes.
That's a person.
Burnt Sushi's actually... Yeah, Burnt Sushi is the username of the guy that writes I'm blanking on his name, but he writes the regex library in Rust, Andrew Gallant, which powers the ripgrep tool, which is a tremendously fast grep implementation. But he's also even very honest about it's not the answer to every single problem. There are a couple domains where if you're trying to search for these kinds of patterns or trying to write these kinds of things, you should just use another crate because mine covers these cases well. And if you are not fitting in that box, that's okay. Just go use a different library and steal my interface or something like that. But there's room for specialization of what problem you're tackling. I really like how Nicole said it is you can have not one central body that says, yes, no, we want this, but everyone can publish their own crate. So if you're an expert in some domain, whether that's embedded or searching or web or async, you can kind of just say, okay, I'm putting this out, and eventually it sort of organically grows a community around it.
I've always wondered if there isn't a library that is a regular expression library that's optimized for a case where you only have 4 possible characters. I know that sounds crazy, but there's actually a really hot domain that does that, right?
Right.
You know what I'm talking
DNA,
about?
right?
DNA, that's right, yeah. And you want to be able to do interesting kinds of matches, and there's only 4 possible characters that you can have. But you can have gaps of various sizes and stuff like that, and doing those kinds of searches and compares or things like that.
I actually have a friend who works in that space, and they write all their own algorithms, and also they write their own storage solutions, because you have, I don't know, terabytes of data that you just need to store, and
it's highly compressible.
It's highly compressible, but you have to like write the algorithms to compress it really well.
Right.
And if you have like multiple members of the same species, then you can like save 99% of your data, right? But
well, even
you have to
across
actually,
species,
like, do that.
most of it's
that too, yeah. Yeah, if you have a banana and a human, you save 60%.
All right. So what is one of the things that we want to talk about is what should C++ users learn from the Boost world, either the language itself or the ecosystem or the community?
I think you mean the Rust world, right?
What did I say?
Boost.
Oh, I said Boost. No, I meant Rust. Yes, sorry.
The last two letters are the same.
Yeah.
Use a package manager.
Yeah, there's a lot of little things that don't feel hugely revolutionary by themselves, and I'd love to hear from Alina and Yash, because I think it's a little bit different for everyone. But I mean, things like cargo as a package manager would be enough for me to switch from C to C with cargo, if you know what I mean. Like that is enough of a change where I'd switch over for that. The open source community and kind of just the general ethos of build tools and tell stories, like really resonates really true in the Rust community, that I see a lot of people of, building the things that they want, sharing it with people, documenting how to use it, and making sure that everyone, if they solve a problem, everyone that comes after them don't have to solve that same problem, both from like an education perspective as well as a code reuse problem or project. So there's a lot of things I like about Rust that I don't think I've found in any language. So my background's largely C and Python and a couple other smaller languages, but it's something that I hadn't found in a community before Rust. And I think any of those by themselves would have been enough to sell me, and the fact that they're all kind of in one place is really huge. And I'd love to see more and more. I mean, I know C++ has things like include C++, which is really great to see, and building kind of more of a community focus around this and addressing some of the things like package managers. I think languages can learn from each other, and it's really great to see more languages in this space, because I'd love to see that cross-pollination of, hey, they're doing that and that works really well, let's do that. Because I think Rust did that with a lot of different languages, whether it was Ruby or JavaScript or C or C++ or Python. If you look at the people involved from like Rust 0.1 to Rust 1.0, it's this changing rotation of Rubyists and Haskellists and JavaScript people and Erlang people. And like, you kind of got this DNA of what everyone liked from the last community that they were in. And I think that left a really positive mark on Rust. And I'd love to see Rust start to propagate that, whether it's the borrow checker or the package manager or just the community and documentation focus. But I'd love to hear Alina and Yasha's take on that as well.
In my case, I also like the package management system a lot, because at least in game dev, you can, the crates that we're using are pretty minimalistic in a sense that if we specify what we're using, then we can also specify the dependencies that we want to also pull in for that specific crate if we don't want to use all of the features for it, for example, or if we want to use a specific feature that depends on something. And all of this is usually documented pretty well. And again, another thing that I like is how easy it is to kind of document things automatically, and it all goes online if you're publishing the crate. There are, of course, it isn't perfect. I don't think any language is perfect, and there's so much to still develop in Rust. But it was a really huge thing for me to see just how elegant it is in comparison to C++, where in my experience, I would just, if I needed to use an external library, then I would just copy the files into my project and use CMake or something to tie it all together and so on. And this is also a thing that kind of bothered me, is that I want to use a specific version of something. For example, I don't want to use a library that's already updated, where an issue, for example, on GitHub got updated and my library is outdated at that point in my project. With Rust, I can actually like specify the version or it uses and so on. So it makes debugging and just the cleanliness of everything much easier in a way. This is something that I think C++ would benefit a lot from. It's just another thing I was thinking about in comparison with C++ is that if I would look at what's presented at the conferences or what people are talking about who are kind of like C++ language nerds themselves, then there's not a lot of overlap with what's happening in the industry, in my opinion. It's just from my personal experience, because in my experience, companies, mostly all different companies, have rules for what can be used from C++ specifically and what shouldn't be used at all. Mostly a lot of the interesting features that get developed for C++ are almost like never used or advised against as not a good practice or something. And then the whole question of like objectively good code or objectively bad C++ code and so on comes in as well. So like every company has their own version of what's a good C++ code, and nobody seems to kind of agree on this as well. Whereas with Rust, it's much easier for all companies to kind of follow the same rule set, so to speak, because you don't really shoot yourself in the foot with the language. So this is also something that I found really interesting.
There's more of a consistent idea of best practices across Rust. Is that what you're saying?
I think you might be muted, Alina.
Oops, sorry. Yeah, yes, this is what I've been thinking about more, is that when people tend to kind of argue what is better, Rust or C++, I think we shouldn't even focus on the on comparing those two languages in this way, because inherently a lot of people, for example, actually enjoy, for example, looking for lifetime errors, even though it sounds kind of illogical that that could be the case, but that's a part of what they enjoy doing. And in C++, maybe having like different kind of standards in different companies is sometimes actually good. There could be places where that's good, and kind of this more decentralized community, in a sense that it's not as coherent as the Rust community. It's hard to say which is better in this case. It's very, very subjective. But I think the core thinking behind Rust is to have kind of a uniform way of writing correct code, or that everyone who's using Rust is basically using it in the same way. So that's something that I found is basically just reduces debugging time by a whole lot. And it's something I think is very beneficial in the industry.
Okay. Yash, did you have any comments? I know you missed part of what Elena was saying because your system was cutting in and out.
Yep, had to switch browsers. Do you have anything to say? I guess the question was, what can we learn from each other as languages? Is that more or less accurate? Yeah. So I guess my best answer to that is what I really like about Rust. I think James said most of it, but I just want to reiterate it because I think it's so important. Is like the open culture of communication. of like sharing proposals in the open, of early prototyping and being able to publish it on Cargo, be like, check this out. And people are like, oh, that's great. Or like, doesn't quite do what I wanted to. The RFC process is part of it. You can just join on Zulip to join, all the language teams' communications. You can read all the conversation on GitHub. You can watch back the meetings on YouTube. I think that and lots of people write blog posts as well, including myself. And I think that openness of communication, at least I didn't experience in Node.js. And I think may not be as prevalent in other languages as it is in Rust. And yeah, more of that. I've seen Swift very successfully. I'm not sure if they were inspired by Rust, but I think they probably saw it. They have this really cool proposal mechanism that they go through. It's not quite PEPs, but they call it something. I don't know what it is. I'm not a Swift programmer, but it's this really pretty website, very glossy, very nice. And every single change to the language has a formal section on this is the syntax changes to the, to the grammar. And I was like, oh my God, that's so good. And I don't know, that stuff like that gets me really excited. I think if languages adopted that, that'd be great.
There is something about the just sheer size. We've all been talking about package manager kinds of issues and how it's such a tough nut to crack in the C++ world. And part of the reason is that if you came out with a new package manager, and a new one is probably not the right solution, but if you came out with a new package manager, the problem is, well, there's all these libraries out there that are not covered by that, even though objectively you might say, well, yeah, but we've done a few hundred of them or something like that. We've got a really good start, and this is more than some languages start with at all. But there's so many out there for C++ that's what, it's such a staggeringly hard project to think about, well, could we get all of the libraries out there covered by a package manager? Whereas if you're starting with a new language, it's well, we only have a few, so we'll get these started, and then, they all grow into it. And so it's kind of this weird expectations kind of thing. If I expect a package manager to work in C++, I expect it to work for thousands of libraries. But if I'm on a new language and there's only a couple of hundred libraries out there, then the expectation is very different.
I would also say that C++ has a problem that many newer languages don't have, which is we have 10 different build systems that all have distinct interfaces. As a package manager dev, the biggest pains in my side are different package managers. So CMake is fine. Don't use anything but CMake, and I will love you. That's basically it. Seriously, so many package managers, and some of them don't work on Windows, and some of them segfault a bunch, and if I'm using Rust, I'm using Cargo. That's the only build system I have to consider. But if I'm in C++ land, if I want to build a new package manager, I have to figure out how to describe the build systems for VC package, 1,300 different projects. And some of them have different build systems on different platforms. Especially older ones, you'll get MS Build and Make or Auto Tools or whatever. And it's so hard to get everything to work together. And that's building the libraries. Now you have to and then once you build them, you have to think about linking them, right? Now you have an end-to-end problem where you have to figure out how to link 1,300 libraries with 10 different build systems. And it's just this is a nearly impossible problem.
One of the powers and made the success of C++ was that you didn't need to have any particular build system or any particular thing. That was its power. But then what that means is everybody went out and built their own way of doing it, because nobody decided, no, we should only do it this way. And then you end up with the situation we are, which is a huge ecosystem with many different flavors to it.
I wonder if you mentioned that's a power to it. Do you see that as a superpower, or do you see C++ succeeded despite its lack of a package manager? I know it's hard to look back because there weren't really package managers other than maybe like, Linux distributions as a package manager, more or less. But do you see that as an actual benefit that C++ had, or do you see that something that C++ was able to succeed even despite not having a package manager?
No. I mean, nobody thought that that was an important part of a language at the time. The ability to be able to be usable by anybody with any kind of, they didn't even have IDEs back then, right? It's just all you need. If you have text and you have a compiler and you have a linker, then you can write C++.
Well, the original success of C++ was dependent on the fact that all you needed was a C compiler, and everyone had a C compiler available, right? Like, well, originally.
I mean, yeah. But that's what I'm saying is it didn't require any particular adherence to any particular thought about, you have to lay your files out in such a way that your headers all go in a folder over here and your documentation files go over here and your test files go over here. You could do whatever you wanted. Of course, then the problem is that means everybody did. And so now we have this ecosystem where everything is done very differently. And so newer languages will have things that were just not considered at the time, such as, here's how you document things. This is the way you add documentation so that a tool can come along later and aggregate all your documentation. That's the kind of thing that's built into some languages that nobody would have thought of back in that, or I shouldn't say nobody would have thought of, but nobody thought it was an important feature to do. And so we have this kind of thing. The expectations of what a language has changes over time. And so at the time, nobody expected you to have, the idea that you would just download a library off the internet. What would that be? It's like, these things just didn't make any sense. And now nobody would think about developing a language now where you didn't have some kind of solution for, CPAN or whatever the tool, whatever the shared library environment is for your particular language. It would just be insane to do. Nobody would even think about doing it. Or if anybody did, somebody would come along and a leader say, well, obviously we have to have a package manager for this. And so I'm inventing that. And, once you get one, so at this point, CMake, I think, has the momentum to be the choice to make. But the problem is that didn't happen early enough that everybody's on board with that. So you have a legacy of tons and tons of libraries that aren't developed under CMake, and you have this momentum. There's it's this trade-off between what people expect of new languages and what we live with in the legacy.
Ooh, question for the C++ programmers here. I saw a really cool talk. I swear it's related. I saw a really fun talk at CPPCon about Microsoft's coding guidelines, and they mentioned like a mode. They were talking about like all these rules, borrow checker stuff from Rust that they were introducing as lints for C++. And they mentioned at some point some kind of mode for the compiler where you can't turn those off. I'm just curious, what do people think of that? I thought it was interesting. Did that question make sense?
So I think this was a static analysis and enforcement of the core guideline, the C++ core guidelines, so that you could have a mode where your compiler wouldn't let you disable warnings and things like that. And if it goes, no, I'm pretty sure this is wrong, it would just tell you, no, it's wrong, and not compile. Sort of like the Rust model where it says, no, you shall not pass until you convince me this is correct, kind of thing.
Yeah, so this is a big thing in my team at Microsoft. So Visual C++ has been focusing a lot on static analysis like this. And I think it's a really awesome effort. And if we can get people to actually use it, it will make the world of programming C++ like many times better. The only concern I have personally is we don't have the type system for it. So we don't have lifetimes built into the type system. If you have a function that takes a pointer and returns a pointer, there's no guarantee that those pointers' lifetimes are related, like stirdup. it returns a static pointer or a dynamically allocated pointer, but in Rust terminology, like a static lifetime pointer. And you don't like know that from the type system. You can't tell the difference between stirdup and, I don't know, ID, like identity. And so you have like a big issue where it's very difficult to actually work for all programs without a bunch of annotations.
Well, to be fair, functions like stirdup tend to be automatically flagged by most compilers these days anyhow, saying, right, you shouldn't be using this potentially unsafe function. But that's, I guess, only in favor of stir in dup, so maybe I'm making too fine of a distinction there. But for my part, a big part of what I do when I'm teaching C++ is to tell people to use all the tools, have all the warnings enabled, use everything that's in there available to them. And right now, if you do that, if you use all of the tools, all the static analyzers, all the things that are available to you, you get a lot. How do I want to phrase this? It's much harder to do something wrong. Yeah. And it becomes very similar to Rust in those regards. The same kind of things that you push back on, like the fact that Rust doesn't have any implicit conversions built in. If you turn on -w conversion, which is really hard to convince C++ developers to turn on, then they get the same kinds of problems, right? So, or the same, not problems, but the same kind of feedback from the compiler. Hey, you're doing a potentially lossless thing here, or lossy thing here. You need to adjust this or whatever. So I wonder, I'm agreeing with Nicole. We just have to convince people to turn all these tools on.
What I always wanted in my tools, and I think, if you're writing your own makefiles, which of course, I always was on a team where somebody else got to do that. And I'm very, very glad that happened. But I always wanted an easy way to just go in and say, see these files here? Those don't belong to me. Don't give me warnings there. Just compile them. See these files here? I'm working on these files. Throw every possible warning, every suggestion about how I could improve this. Because I was always working on, just a huge code base that there were other people on the team. So it wasn't just a question of library versus app code or something like that. But no, these are my files. If there's anything to be warned about these files, let me know about it. And be really, really strict with these files because I own these. And then these other files, don't tell me about warnings in there because that's not and I don't want, because I think this is one of the problems is I was working on a very large project where for reasons that we don't need to go into, we had to switch tools in the middle of the project. We switched compilers and we just got scads of warnings. It was just eyes glaze over. So what did we do? We had to turn off all the warnings. I mean, there was no other way to do this. You couldn't fix all those warnings in one pass. It just wasn't happening.
-i system.
-i system? What is
yes,
this?
that tells the compiler that that's a system header include directory and it should not be giving you warnings from it. That's available on every compiler, I believe.
Right. That's what I want, except I want a much better granularity than that. And it's not necessarily a system, but but the point is exactly what you're saying, which is yes. I don't control these. Just take those as a given.
I think that there's this thing in Rust where they have like standard warnings and you can add pragma, like the equivalent of pragmas, and turn warnings on or off. And that seems like one of the frustrating things in C++ is that you don't have standard pragmas for warnings. And so that would be, like solve that problem, right? Like pragma warning level 4 or whatever, right. Whatever the equivalent on Clang and GCC is.
I wonder what the uptake would be. So I mean, Rust sort of has a policy of safe by default, allow you to opt into the gnarly stuff if you want. So I mean, Rust kind of does that at a language level by things like unsafe. You can still do the crazy stuff, but you have to pretty explicitly to the compiler say, here I am doing the bad things, and I promise that I know what I'm doing, and I promise it's okay. Or warnings and things like that. I've always wondered why none of the major compilers, whether that's Clang or GCC or anything from the Microsoft tool suite, didn't just kind of say, we're shipping with all of the warnings, like kind of like Jason was saying, this is all the stuff you would want to turn on day one, if you don't want these, you can opt out of it. But is other than just kind of the wall of warnings that everyone with any non-greenfield C++ project would get, has there been someone that's tried that in the past?
There's one of the problems is that you can get warnings and you can get warnings. In other words, one of the cool things about is that there was actually, for GCC, there was actually this, you can turn on the Scott Myers warnings. And that sounds like a really great idea until you turn it on and realize they didn't really do a good job of capturing Scott Myers warnings. Because Scott would say things, this is true, except in this case. But there is no way for the compiler to figure out that was that case. So you've got just tons of warnings. I've actually fought with situations where I was using, because this is cross-platform code, I have one compiler, two different compilers that look at the exact same code. And so I have a situation where I'm saying, if this, return this, else return this, and then I get a warning because I'm falling through the bottom of my function without returning, right? Do you follow? I mean, I have an if, it's either going to return here or it's going to return here, and if it doesn't, then it falls through and I don't return anything. Well, I get a warning saying, well, this is falling through without returning anything. It's a function that is falling through. It's like, well, no, it's returning. Okay, fine. So at the bottom, I say return 0. But then I get a warning from the other compiler saying, well, that is never going to be executed. It's like, oh.
I want to add one more thing that I wish C++.
Wrong. Yeah.
Yeah, I want to add one more thing that I wish C++ would adopt, and that's Rust's error messages, because I have also never worked with a language that has a higher signal to noise ratio. Like when the compiler is very strict, and the compiler will yell at you often, but the compiler is almost always right. Like very rarely have I had an error come back at me and I go, like you said, like, no, it's fine because I return in this case or this case. Like when Rust is strict and unforgiving, but it goes, see, nah, and I'm like, you're right, compiler. And like, that's kind of a relationship with a compiler I've not had before Rust.
But I understand that's because you have a compiler, right? Are there multiple compilers for Rust?
Are, but not in a reasonable sense.
Okay.
Yeah, that's the main difference. If you agreed, I'm only going to use Clang, then yeah, you would get that.
Right, and you could then have pragmas that worked for all the warnings and stuff like that. I mean, if you only have one compiler, that does simplify the world, but it also limits the world a little bit too. So.
But then
is there a reason that Clang couldn't just do that?
Well, but
if Clang had really high signal to noise ratios on that.
Well, I think it does. This is one of the claims. This is one of the things that launched Clang into acceptance, was that it really revolutionized the quality of error messages.
And that kind of warning
demos, right? What?
That kind of warning that John was referring to, where you get, like, oh, you have a fall through case or whatever here. I haven't seen that kind of disagreement between compilers in at least 2 or 3 years, I don't think.
Yeah. Those kinds of things get better. I was just saying that you can get into a situation where a warning that makes sense is only a warning because there are times when it may be right, and so you want to investigate it. But there are situations where it was kind of tough for me to write code that was warning free on multiple compilers. There just wasn't any good way to say what I was trying to say, in a way.
I will say here that Rust benefits from these not being warnings. They are like errors in the types, right? So unlike C++, where returning a pointer to a temporary is a warning, it's undefined behavior all the time, but it doesn't actually, it's not like an error, it's not ill-formed. In Rust, it's actually ill-formed. Like, it is ill-formed to have lifetime errors. And so it's very easy to error on those things because it's literally not a valid Rust program if there are lifetime errors. And they have some set of, lifetime types that they use. But like C++, there is no lifetimes in the actual language itself. It's all just static analysis.
Well, I'm going to have to issue a warning that we have exceeded the lifetime of this episode.
It's been great, and learning a little bit about another language, but also more another ecosystem, another way of approaching things, and being envious of the great cargo that you have. the package manager. That's wonderful. So I'm going to ask you all to join me in wishing all of our audience safe coding. So please, safe coding, everybody.
Safe
Safe
coding.
coding.
Safe coding.